Assalamu alaikum wa rahmatullah. We are very proud to present our research topic at the third International Conference on Big Data and Machine Learning. Me and my team, we thank you very much for the effort we have made to render this conference successful remotely because of this time of epidemic. I am Mohamed, engineer and PhD in computer science at Abdelmalek Saadi University. Via this presentation, we will present our research topic entitled Metadata Modeling for Data Lake based on Dynamic Ontologies. The outline of this presentation is designed as follows. First of all, I will start my introduction to define my research topic and give you a clear idea about it. Then we present the literature review related with our topic. Afterwards, we present formalization of data-like information system. Before showing the result, we will present the main contribution of our topic and closes the presentation by conclusion and some perspective. The rapid growth of massive data requires the question of its storage. To address the big data challenge and more particularly volume and variety, Data Lake is proposed to make the big data issues by offering the data storage without a predefined schema. In this context, Data Lake meets these needs. Then it appears as a powerful and efficient solution to big data heterogeneity that represents the major advantage by comparison with its classical solution data warehouse that require a costly data preparation layer that consumes a lot of time in any data project, almost 60% of the time allotted to the project. For this reason, Data Lake remains the recommended solution to handle the big data issues. However, as the advantage of the absence of schema are very clear and well defined, but in the same way the absence of schema it also contains a critical drawback, which is represented by transformation or turning of the data lake to data swamp. That means useless data, or what is known also by not actionable data. In this slide, we aim to present the main purpose of our research topic and limit the problematic, or what is known by the framing the problem. So, the main purpose of our research paper is both. The first one is to provide the more complete vision and procedure 360 with the ability to search, understand, analyze, navigate between the different data sources stored in the lake. And the second one is to examine the impact of metadata management to take the advantage and the power of this efficient managerial ability to ensure the successful building of a data lake as the information system expected for many organizations to follow their competitive. Then, our research paper tried to respond to this question. First one is how to handle the different data sources stored in the lake, whatever its format, may be structured, semi-structured, or unstructured data, regardless of the format of data in general. And second one is how to avoid the dilemma of the data lake that is formulated as follows. How to avoid the transformation of data lake into data swamp or not documented data, or what is known also by useless data or not actionable data. In order to don't reinvent the wheel, related works appear necessary. In this context, many researchers they agree on the importance of metadata management system as a powerful and efficient solution who can start with it to handle the issues and the challenge and use it by the big data. But the question that arises, with what approach we can start to implement and operate a data lake? Of course, several approaches help to organize the metadata management for a data lake system, but most of them focus only on structured and semi-structured data. But what happens with unstructured data or not structured data? Formalization of a data lake may be one of the important steps in the design of data lake information system. In this context, data lake is based on a flat architecture. It means in the data ingestion layer, data is stored as is in your native format. As we can see in the table below, we show a global overview of data lake resources. In our data lake design system, the data lake is composed of a set of a document, and each document is described by an identifier that represents the original path of data source, and set of metadata, that means description data, or what is known also by data about data. In the most of cases, metadata depend on business needs, maybe technical, functional, administrative, among other types of metadata. In our case, we have implemented Apache Tika as a generic and extensible API that refers to application programming interface, capable to extract the content and the metadata from the various data sources stored in the lake. To keep things simple and clear, we offered the UML diagram below, which shows us two key components of data lake: data and metadata, or what is known also by data about data. As we can see in the diagram below, we have the data lake repository package composed, or in the jargon of UML, we have strong aggregation between the data lake repository package and the document classes. Indeed, each document resources is described by a set of metadata. This diagram may be very clear and show a global overview about data lake design system. The main contribution proposed from this paper handle metadata management by implementing dynamic web ontologies to effectively manage the different data sources stored in the lake, whatever its format. These options show the main contribution for the literature because a lot of papers focus only on a specific kind of data source. Even for the paper which treat the unstructured data, most of them focus only on textual data, but in our case we handle all types of data, which show the efficiency of our work. The results generated from our contribution presented as we can see in figure below. In fact, this ontology generated from Protege software defined the existing contract between users and our data lake. Furthermore, to fully understand each type of data ingested in the lake, a metadata interception spider is applied. It shows a set of descriptive metadata help to well understand the content of the lake. The presentation came into close with conclusion and some perspective, thereby improving the data quality of data organization via metadata management is becoming a brilliant technique in the world of data management. This contribution can be improved by adding machine learning techniques, for example, to extract the hidden topic represented in the various data sources stored in the lake. Moreover, this assumption can be interpreted as a future perspective. Thank you for your attention.